Hello class, this is a video tutorial on graphing combined functions part 2. The same procedures that we've applied in the previous example can also be applied to the difference and product of functions. Graphing quotients of functions, that is functions that look like this, f of x on g of x, so this is a quotient of a function. Those will be learned later. For this video, we'll be looking at the difference of two functions. Well, as you can probably see, this is the table of values, or a combined table of values for f of x and g of x. These are the same functions we saw previously. But for the last row, instead of taking the sum of the values, we take the difference of them. So negative 48, take away 5 is negative 53, negative 15, take away 4 is negative 19, and so on. Well, from here, we simply just take the values and we plot them on and we graph, we approximate or sketch what appears to be the difference of two functions. Unfortunately for this one, the first two are beyond the range of the graph, as well as the last two here as well. So we're just going to have to work with what we have here. So negative 2, negative 3. Negative 2, negative 3 is here. Negative 1, 1. Negative 1, 1. 0, negative 1. 1, negative 3. 2, 1. And unfortunately, that's all we have to work with. From here, I can see the graph being drawn as follows. Like so. Comparatively, it's already a lot, more squished in vertically. So it's lower here and higher up here compared to the other one, which was the sum. It looked, from what I can remember, looked a little bit more like this. But that's the general idea when it comes to the difference of the two functions. But now we're going to look at doing the same procedure that we did, just looking at the graph, in order to find these, to sketch the difference of the functions. As we saw previously, As we saw previously, there were some rules or some guidelines we could use to help us sketch the difference of two functions. So let d of x equal the difference of two functions. So f of x minus g of x. Now let's think very critically here. When f of a is equal to 0, so 0, it becomes the negative of g of a. So let's say we have a 0 here minus, and let's say g of x is 3. Well, the difference of the two, so 0 minus 3, is just negative 3. But if we had, say, 0 minus 2, this would become positive 2. So the sign of g changes. So if this were a positive 2, when this is 0, it'll become negative 2. If this was negative 3, and this was 0, this would become a positive 3. So let's find these points first on our graph. So when f is 0, so here we have it. So when f is 0, g becomes its opposite sign. So instead of positive 3, it'll become negative 3 at 2. So there's our first point there. Our next point here is when f is 0. When f is 0, g, positive 1 here, becomes negative 1. lastly here as well, when f is 0, g, which was at -1, becomes +1. Okay, so these are the first 3 points that fulfill this rule. When g is 0, the difference must be just f. So for example, let's say f is +3 and g were 0. Well, 3 take away nothing is just 3. So let's find all the points where g is 0. There's only one point of intersection of g. When g is 0, f stays where it is. So we're done with that one. When f is equal to the negative of g, actually I'm going to leave this one to last. This one's the hardest one to find actually. Let's find first the points where they are equal. So when f and g are equal, the difference must be 0. Well, the reason for that is, well, let's say f was 3 and g were 3. 3 take away 3 is 0. Okay, so let's find the points where these meet. Here's one there. So that will become a point of intersection, because when we take, let's say, from the looks of it, it looks to be about 2.5. Well, f is 2.5 and g is 2.5. 2.5 take away 2.5 goes down to 0. Likewise here, point of intersections on the difference becomes a root, or a point of x-intercept, and one more here, those become an x-intercept. So those are more points we can use. And the last one now is when f is equal to the negative of g. So like in the previous one, let's take a look here. In the previous point, we found points here where this is g and this is negative g. Because remember, the height at this point, this height and this height were equal, but they were of opposite signs. So when f is equal to negative of g, so which is, it was about here, so that height is equal to the negative of the g version. Let's actually move it a little bit further. Whoops. A little bit further this way. Oh, sorry, my apologies. So that height is equal to, oh, well, you get the idea. It should have been around about here. This height is equal to the negative of that height there. So at those points, so think about this. So this height minus the same height, it would double in length. So this point here would go all the way down somewhere there, which is off the chart, off the scale that we have, sorry. Another one where we can find that was at, let me take a look at my notes here. At 2.2 was, so this height is equal to the negative height. There it is. So this point here would double, because f take away the negative of that point, so it would double like so. And the last point that we had was here, 2.1. I believe that is the same height, oops, that is the same height as third time's the charm. This height was the same height, but in the negative, somewhere at 2.128 it says on my notes. So let's say that this point would double it would double in height. So up like so. And using those points, we can graph our function. Looks to be something. Oh, let's try again. Oh, no, it goes a little bit further down. Like so. Oh, very rough sketch here. Let me try one more time here. They're equal. Sorry, completely missed it there. That's better. It goes underneath. Now, we also know it's underneath this function because it's being subtracted by something less than it. So it couldn't possibly be above it because it's being subtracted by some value. So it would have to be underneath. So I hope that gave you an insight into sketching the difference of two functions, both using a table of values, but more importantly, using these features here. Hope to see you in the next video. Best of luck.